Hello, my name is Sean Durandetto. I'm making this video to demonstrate and show you how to use regular expressions in Java. So, the reason why you would want to use regular expressions is to be able to take a string and check if it makes certain criteria, to check if it makes if it matches a certain pattern. It could be used to find substrings within strings. It can also be used to easily fetch these substrings from larger strings. So first things first. What is a regular expression? Some of you who have used other programming languages or maybe use Linux might be familiar with regular expressions. But in case you're not, regular expressions are basically a formula to sort of define a pattern of a string. So for example, let's say if you wanted to check and see if let's say you wanted to define a pattern where a string ended and began with the letter A. You would create the regular expression you would use would be something like A star, A asterisk, or actually A plus, A plus, as the basic form of the regular expression. That would be used to find all to test if a string ends and begins with the letter A. Now, sometimes, and this is the case in Java, you have to add a little extra information. So what you have to do is you have to put a period and then an asterisk. The period and the asterisk essentially means 0 or more of any character. So if we break this whole thing down, the A star or the A plus essentially means either 1 or more A's, and the period with the asterisk means 0 or more of any other characters, and then at the end we have A plus, which again means 1 or more A's. So to sort of state what this whole thing means as a whole, we would say 1 or more A's followed by 0 more of any other characters followed by 1 or more A's. And that would be used to filter out strings that start and begin with an A. In Java, regular expressions are used through the pattern class. Yeah. So now on to actually creating a pattern, a regular expression. To do this, you have to first import java.util.regex.asterisk. The asterisk just means that we're going to import everything in that package. Specifically, we want the pattern and the matcher class. We want pattern and matcher from that. But for this purposes, we're just gonna import everything. To create so to create a pattern, we create a pattern class, which we'll name pattern, and we'll equal it to and to create the pattern object, instead of using a new keyword, much like you would use to create any other object, what we actually do is we call pattern.compile, and then we put in a string. The string will be our regular expression. Likewise, to create a matcher class, now to actually use the regular expression, we will need what's called the matcher class. Creating a matcher class is similar to creating a pattern class. We would create our matcher variable with the name matcher and assign it to the result of pattern.matcher, and the input for that is a string, which is what we want to sort of compare to our regular expression. The string we want to compare to our regular expression. So, to sort of get an idea of what's going on here, we're just going to go over some demos. First things first, we're going to create two strings. The first one here, to test, is what we are testing. And test with is our regular expression, which I'll just rename to regular expression. So for to test, we have cat, and a regular expression is dog. So we want to see if cat matches dog, which, as we know, it doesn't. So first things first, we create our pattern class by compiling our pattern with the regular expression. We create our matcher class by getting the matcher from our pattern with what we're trying to test. What we do next is we call matcher.matches. This will return a Boolean value, which is true if the test value to the test string matches our regular expression. I put a little print line here which will print the result. Now, alternatively, if you wanted to do the exact same thing, you could do what we just did up here all in one line by calling pattern.matches and supplying the regular expression first and the test value second. This will test if the test value equals regular expression and will return true if it does and false otherwise. This does the exact same thing, however, we cannot reuse the pattern. So if we want to compare other strings to our regular expression, it will end up having to recreate, a pattern class each time. So if we want to reuse a pattern, we should use the first example, and if we want to just calculate a single item, we should use the second. So what we're going to do is we're going to just quick run this. And here we can see that we got, the expected results, where cat and dog are not the same strings. They do not compare equal. So that showed us sort of how to use pattern and matcher. Now we're going to move on to how to reuse our patterns and sort of show how we can sort of test multiple inputs to see if they equal the same, or test multiple values. So in this new demo, I've created an array of strings and initialized our new array of strings with the following strings. What we are testing is to see if they start or end with an A. So what this regular expression means is we have lowercase a followed by 0 or more of any characters followed and ending with an A. The period means any character, and asterisk means 0 or more of that character. So if we look at any of these strings here, the first string in the array would be true because we have, it starts with an A, has 0 or more of any other characters, and ends with an A. So what I did here is I first just output, have a print line just to show what we're doing, and I created a pattern like similarly to how we did in the first demo, and I created a for loop that will loop over the entire array. Inside the for loop we will create a matcher object based off of the string at index I in the array. We will calculate if it matches, and after that I have a print line that will print the result. So as we can see here, the first string in the array evaluates true, the second false, the third true, and the fourth is false. You can see that this is correct because the first one starts and ends with an A, the second does not, the third does, and the fourth does not. So now what we're going to move on to is how to use regular expressions to find a value within a sort of a larger string and just grab that value. So what I did here is I created just a random string with a sort of like hidden message. This is a string that we're going to be comparing to a regular expression to sort of pull out this message. Here I have a regular expression. Again, we have the period, which means 0 or more, or which means any character, asterisk, which means 0 or more times, followed by of this little tag I made. This doesn't really mean anything. They open, greater than message less, or yeah. This is just the tag I'm using. This can be any string. And here I have an open parentheses and close parentheses. What this is this is a grouping, and this just tells the pattern, the matcher that it should save this, save this and index it. And here again I have another tag followed by another any character 0 more times. So in total, to sort of state this whole regular expression, we would say any characters 0 more times, followed by sort of, you know, our little caret message, caret, followed by 0 more times of any character, followed by our caret message, MSG, caret, followed by 0 more of any character. So what we are attempting to do is to save anything that is between our little message tag here. So what we'll first do is compile and create our pattern. Then we will get the matcher from that pattern. Next, we first have to make sure that the that we actually have found our message, our little message that we're looking for. So what matcher.find does is it looks for the first pair of parentheses, and it will return true if it does find it. So if it finds that, it's going to move on to here. It will call matcher.group. What matcher.group will do is it will grab the whole entire sentence, the whole entire string. Matcher.group is actually the equivalent of matcher.group with a 0 in it. So what the 0 means is 0 is the index of the group. So the entire string itself is the group 0. Or I shouldn't say, the entire anything that meets this regular expression is the first group. So there's sort of an implicit little pair of parentheses outside of this. Group 1 is actually our next set of parentheses, which would be these ones. And what this does is it will grab anything. It'll grab the parentheses. It'll grab what's in between the parentheses. So we'll have a little print line that will output, the result of group 0, and we'll retrieve group 1, which will hopefully grab our message, and we'll output that. So if we run this, we'll get our first group, which is the entire regular, whoever matches the whole entire regular expression, and we'll also get our group with the index 1, which is the message we're looking for, which you can see is actually here in the string. Moving on to our last demo / example. So another neat thing you can do is you can use groups to sort of with strings as names instead of actual numbered indexes. And for this, I'll also be sort of demonstrating how to sort of make a more sort of advanced, more complex regular expression. So what we have here is what we're trying to test. So this might be something that you might get as an input from the user. Notice how there can be, a bunch of spaces, and you might want to make sure that this is actually number. Our regular expression will actually help us take care of that. So first things first, let's move on to our regular expression itself. What we have here is 2 backslashes and an S. So what we are actually looking at is just to write one single backslash and an S. What this means is any characters that are a space. So any spacing here. We need to put a backslash behind that to sort of escape the next backslash, which is something you have to do because of the Java strings. But just know to use that if you need to use a backslash, you need to put another one behind it. So what we are saying here with this little piece here is 0 or more white space. So any white space will be sort of this will means any white space behind this timeout here. The next thing we have is a capture group, like in the previous example. This will sort of save the location, or this will save the substring of anything matching the inside. Question mark, and then our 2 caret symbols. So the question mark and this little caret symbol, this little greater than, is the opening for our sort of key value. This, and then we have command, and then we have our less than symbol. With the command inside this will be our key, and essentially this means just to store everything inside this little capture group with this key. So in this instance we'll be saving everything in here with the key command. Next we have some stuff in between 2 brackets. Brackets just mean anything that fits what's inside of it. So here we have A to Z. This means any lowercase letters A to Z, and after that we have capital A to Z, and this means any uppercase letters A to Z. And what this will do, what this in its entirety means, is any lowercase or uppercase values A through Z. And of course, and now next we have a plus, which just means 1 or more. So this capture group will effectively take any letters A through Z that occur 1 or more times. So I'll look for anything, and then it'll save it with a key command. Next we have another 0 more white space. This next capture group will do the same thing. It'll save the this capture group with a key value. In this case we have another pair of backslashes followed by a D plus. The D just means numbers. So this effectively means 1 or more number characters of any type. We have another 0 more spacing, followed by another capture group. In this instance we'll be saving this capture group as unit, and again we have another lower and uppercase, or 1 or more lower uppercase values, followed by more white space. So in its entirety, this expression effectively means 0 or more white space, followed by where we'll then capture the strings or any we'll then capture the string that has any lowercase or uppercase characters, 0 more of them, and we'll save that with the key command. This will be followed by more white space, 0 more white space, followed by the next capture group, which is 1 or more number characters, which are saved with the key value, followed by more white space with another capture group that will again save any lower or uppercase characters of 1 or more of them with the key unit, followed by more white space. So we'll create the pattern, then we'll create the matcher. We'll check to make sure the matcher has found our regular expression, otherwise it'll throw a exception. And what we'll do now is we'll find the group with the key command. We'll get that as a string. We'll do this by calling matcher.group with the string command. The string command is just the key that we used up here. We'll output that. We'll do the same thing for value. We'll grab the group value and look at the string. We'll output that. And we'll do the same thing for unit. So now here I just have a separate variant where we do the same thing, but we use numbers for the indexes. So how this works is the index number of our capture groups are ordered by opening parentheses. So here we have our first opening parentheses, and as capture group 1. Here we have our second, as capture group 2, and here we have our third, which is capture group 3. And these will do the same thing. They will return a string which will again store and output for each one of them. So we'll just test this, and as you can see, we got our individual strings and output them correctly. So as you can see, regular expressions can greatly help with sort of parsing a string and searching a string for items, rather than defining loops and sort of creating substrings and comparing those. We can create patterns and matchers to do that for us. Regular expressions themselves can be a little tricky to use, but once we get used to them, we can sort of greatly reduce, our time for doing these types of operations in terms of development time. That's all, and thank you for watching.